Okay, so let's start for videos. Okay, so we finished regression, we finished classification, right? After this, we are going to look around what is clustering. So in clustering, there are two techniques. One is k-means clustering, another one is hierarchical clustering. Okay, so we'll see k-means clustering. It's a very simple machine learning algorithm, but effective and potential algorithm. Mm, Let's see. Okay. So k-means clustering is a method that comes from a signal processing and uses the k-means algorithm. It aims to group a set of n observations into k clusters. So we are already aware of the k, I mean, how to find out k and how to fix the value of k. And it continues in machine learning algorithms. K means clustering. There is another one is called k nearest neighbors. There are two things, the k and then and k means. Right? So this k means it's really very important and critical at some point. And for some use cases and some problem statements, k means just easily solve the problem of real-time things. Okay. So it aims to group a set of n observations into k clusters. That means it is grouping under the k value. So each observation is placed in the cluster where the average or the center of the cluster is closest to it, making that cluster its representative. Okay. So, I mean, what is k means and everything we are going to explore. And before that, I want to open up um, k means. So I hope you are viewing my screen. So this is based on all customers' data. If you see, the using this K-beams, I will show you after this. That's it. This is all about the K-means clustering. And before, I mean, once you import the library, once you import the data set, right? Here they are finding it out. I mean, they're taking the value from this place to this place, and they are using the elbow method to find the optimal number of clusters. Okay. So the optimal number of clusters is our main focus in k-means. To find out the number of clusters, we are using the elbow method. There are a few more methods, but this problem statement they are taking as an example of elbow methodology. So if you are considering the value, let's look around the importance first, and then so it is a popular unsupervised model. It is not a supervised model. It is an unsupervised model, an unsupervised categorical, I mean, category data. That is why it is effective. Okay, so uh, there are many methods in the algorithms. If you use for supervised learning model, it has its own structure. But if you are dealing with the unsupervised model, I mean, we cannot define the structure of the data set. I mean, the input flow and everything, but it has its own way of solving these kind of a challenges. At the same time, that is why we are going for K-means, because we don't have a control on unsupervised methodology. Unsupervised in the sense, whatever, say for instance, your SMS, your WhatsApp, your the communications medium, social media platforms, and other channels like YouTube, Reddit, and there are so many, data generation tools or data generation websites, right? We are interacting with them, and those kind of things, we never know, and it is not under the supervision of, I mean, any kind of control. It doesn't have any control systems. And from this, how you are segregating the information, how you are channelizing the information, how you are categorizing the information, that is why the clustering techniques has been introduced. So, say for instance, in Google Maps, you are giving some rating for any restaurant, not only restaurant, any business. Okay, so if you are going for any hardware suppliers, right? After your experience, you are giving some rating, whether it is a positive or negative, that is a different story. But you are just interacting with them, and that is one thing. And if you are going for, companies, any companies, small, medium, and big, I mean, large scale companies, all the businesses are existing in Google Business, right? You are just interacting, and all these businesses segregated and grouped under clustering. And then if it is under clustering, then this kind of comments, this kind of the emotions will be shared, and also with your, I mean, along with your rating, along with your text, right? So it's all coming under unsupervised model, and it is the K means is taking it very very perfectly, and it's just solves the real time. Okay. The goal is to group similar data points together and discover underlying patterns or structures within the data set. Okay. So it states, okay, so there is an algorithm that tries to minimize the distance of the points in a cluster with their centroid, that is called the K-means clustering technique. Okay. So the K-means is taking a centroid-based algorithm. Centroid-based algorithm is nothing but, if you see the, okay, if you see this graph, the center point is a the yellow color, right? The centroids. If you see I mean, the explanation in the graph, yellow is the centroid, um, and violet or purple is cluster 5, and ocean blue is a 4, green is 3, blue is 2, and red is 1. So these are all the clusters, and yellow is the centroid point. So based on this centroid, it is trying to locate, it is trying to group, it is trying to cluster. So these are all the similar patterns of information. Okay. So the green, red, blue, and this blue and purple. Okay. So these are all having similar categories or similar same, the patterns of data. I mean, similar patterns of information, so that it is just clustering based on this centroid point. Okay, the finding out this centroid is the the sub. I mean, the value of, value of k. The finding out this centroid, it depends on the clustering techniques, and how does it work. That is what we are going to see. So main objective of the k-means algorithm is to minimize the sum of distances between the points and their respective cluster centroid. Okay. Just take out your, I mean, once you are ordering, maybe food delivery, or you are booking your Ola, Uber, or Rapido. They are the major players in metro cities, right? So if you are just giving the request, okay, and based on this centroid, I mean center point, the nearest drivers will be located. Okay. So previously we have seen the KNN. KNN is also it's close to this kind of an application, but this is an effective application just to find out the cluster of drivers based on the center point. Since Assembly is located in the other end of the Bangalore in Rajajinagar, he is just trying to book a cab or trying to order food. So based on this centroid, the 1 kilometer radius, 2 kilometer radius, and 3 kilometer radius, that's it. So this cluster will work towards this place because that is the pattern of uh, drivers located under this cluster. Okay. If you couldn't find out any drivers, that's it. It will be closed because if beyond its control, then there is no point of the company and also for you. It will take, and for you, it will take more time. For them, it's not affordable thing, right? It will cost you, it will cost them more, and they can't ask you more. And that is the ideal situation because that is the ideology. This process has come up within 7 minutes, 10 minutes. They are promising to deliver anything, right? And even for cab, it will take sometimes 15 minutes, 20 minutes. That means they are out of the control, maybe out of the cluster. Maybe they will be traveling from this cluster to this cluster to this, and this to this, and so on. That is why in peak hours we'll be getting into a lot of challenges for getting a cab, even for auto. Okay, so that would be the case. So if the driver is traveling from this cluster to this cluster, then they will be asking more money. Okay, so that is based on the number of kilometers or miles. Okay, so that depends on the cluster groups. The maximum the number of miles or kilometers, if it is getting reached, then we will be getting the delayed thing, and we won't get any drivers, and we will be waiting for some more time, right? So this K means it's really opt-in methodology to play around these kind of things. Okay, so how clustering works? So start by randomly selecting K points from the dataset. These points will act as the initial cluster centroids. Okay. So I'm just taking this same example. So how do you? I mean, you might be asking how this centroid will be decided, right? That is what they are saying. It is randomly getting selected. It is not this is the center point and it works. No, maybe I mean, initially, it will be trying from this, and then it will move from this, move from here, and move from here, and move from here, and here and there. It will be just going randomly, and then trying to find out one cluster based on the distance. Okay, so these points will act as the initial cluster centroids. Okay, that is a far. I mean, we couldn't see through our naked eye and how it is, placed. That is the power of algorithm what we are using. That is the k value, and k means it is just getting the average value and where it is getting assigned, and we couldn't see where this getting go and choose all these things. We couldn't visualize. That's what I'm trying to say. So assignment for each data point in the dataset, calculate the distance between that point and each of the k centroids. Assign the data point to the cluster whose centroid is closest to it. This step effectively forms k cluster. So this is this is how it works actually. Okay. Initialization, it just start by randomly selecting k points. K points would be anything. Okay, so these points initially will be acting as a initial central, cluster centroids. Later, it will just trying to, for each data point in the data set, calculate the distance between that point and each of the place endpoints. Okay, say for instance, um, this might be initially, we assume that, okay, this maybe, you can just observe my cursor a moment. Initially, the centroid would be here, and it just thinking, if it is the radius, then it will just, keep on categorizing or clustering the information. If I mean, if it is trying to find out this is a different set of cluster, then it just stops over here itself. Okay, and then it will just, started working to find out the what would be the nearest distance of the center. So this is, if you take this data, the last, in this cluster, these are the four directions, right? In this diagram. In this diagram, if you take it, if you just, calculate the distance, this would be the minimal distance of this entire. So we are just, speaking, and it is just categorized because of the information. Based on the information, it is clustered. It is not that we are just making as a cluster. No, based on the information what we are getting, from the data set, it is automatically formed and getting into the clustering group, getting into the groups. And this is the initialization, and this is the assignment, and how the centroid updates. Once all the data points have been assigned to clusters, we calculate the centroids of the clusters by taking the mean of all data points assigned to each cluster. That's where the verification and the validation is happening. Because each and every time, if you just found out, okay, this would be the cluster, this is the cluster, then it is taking the mean value from all the distances and just sitting in one cluster. Okay, to form this cluster, the K and the centroid, it won't be just, decided just like that. No, it will just see, all the points. Okay, this is a cluster, and all the clustering points, patterns of data set, it is just, coming into one cluster, and then it is trying to form the centroid, so that, it will be equally distributed. That is why we are taking the mean value, the same kind of thing. So this would be the right centroid, even though this green, it is just, going beyond the control of the clustering structure. Even if you just observe this, purple color, it is going beyond, but it is like, kind of an outline. We can't do anything. But I mean, if it is, more and more value would be splitting over here, then this centroid will be moving, and it forms over here the centroid point. But the data points over here, it is high, so that, it will stick to this centroid. So it won't move, because, it is calculating the average, the mean value of all the distances, so that it is, taking and sitting over here. This is the simplest technique, but it is really effective technique. And repeat steps and 2 and 3 until convergence. Convergence occurs when the centroids no longer change significantly, or when a specified number of iterations is reached. Okay. So the final result, one convergence is achieved, the algorithm outputs uh, the final cluster centroids and the assignment of each data point to a cluster. This is very simple and effective. This is how the K means and the centroid point is just, working together, right? So what would be the objective? So the main objective of K means clustering is to partition your data into a specific number of groups, where data points within each group are similar and dissimilar to points in other groups. Okay. So grouping similar data points, that is one, that is our goal. Minimizing within cluster distance, that is another thing, right? And maximizing between cluster distance. Okay, these three things are objective. So how it has been calculated? Grouping similar data points. K means aims to identify patterns in your data by grouping data points that share similar characteristics together. This allows you to discover underlying structures within the data that is we are able to understand. The next thing is minimizing within cluster distance. The algorithm strives to make sure data points within a cluster are as close as possible to each other, as measured by a distance metric, usually Euclidean distance. We already aware of what is Euclidean distance, right? This ensures tight knit clusters with high cohesiveness. It is very, very close to the relationship. Okay. And the maximizing between cluster distance. Conversely, K means also tries to maximize the separation between clusters. Ideally, data points from different clusters should be far apart, making the clusters distinct from each other. So this is how it is, clustered together, right? Uh, I mean, the word itself, how it is getting, how the clustering is meant for. So this is an analysis is a cluster analysis is a technique used in data mining and machine learning to group similar objects into clusters. Okay, so this is the main high income, average income, low income. It is we group them. It is they're getting clustered together. And how is clustering an unsupervised learning problem? And this is that is what we are going to look around. Maybe we are going to just learn. But before that, I want to make sure that what is elbow method and the other things. So this is initially, just to see the thing, the income, it is a debt. So based on income and how the debt pattern would be, these are all, initially it will just, form the clusters like this, and then it will just, trying to um, portray like this. And based on this, first property of K means a clustering algorithm. They just, checking all the directions and the second party. See, don't okay. What they are trying to show you here, it could be any kind of a circle or any kind of a see to identify the property of selection of the information. Don't mind the shape. Okay, that is what they are trying to show you, and also trying to observe, ask them to ask you to observe this kind of information. It could be like this. We never know, right? Sometimes it might look these informations together. Okay, maybe uh, uh, the calculations and the algorithm trying to okay, this might be one of the clusters, or this kind of a pattern, this would be the clusters, right? And then still it is go on and on and on and fine tune by its on its own, and it is getting segregated and it is getting grouped. So this is also a possibility. It is not like that only this kind of the patterns of information, no. So based on the real time patterns, it might be like this, right? This might be the two things like a perpendicular axis, and this is also like that. So don't get a assumption that this would be like this. No, never. In machine learning, anything and everything can happen. Okay. And then the market research, the customer segmentation will be, working on, and how the document should be. So these are all these clustering in real time for computer vision techniques. So these are, these are all one of the methodology, inertia based on the intra-cluster distance. Okay, that is also done index. These are all very, very um, the minimum and the maximum inter-cluster distance and the maximum intra-cluster distance that is called as a done index. It is maximum, this kind of methodology we never, go in depth, but only the, how many, if you say this, yeah. to find out how many clusters, how many k-means value, how the initialization process is just happening, and to find out what would be the right methodology of k clusters, and they'll be chosen. Okay, so we'll see what is elbow method. This is all the other side of we now know that inertia tries to minimize the intra-cluster distance, and it is trying to make more compact clusters. And these are all based on the centroid point, how the centroid point is making its own decision each and every iteration process of the information. Okay. So each and every iteration, this would be the process, right? Along with the distance between the centroid and points, the done index also takes into action the distance between two clusters. Though it is just, it might be, looking very, very simple and effective, the back end of the information, back end of the k-means and centroid, this is how the property of, this is how the working culture of, working nature of this technique. So if you just see just 10 lines of programs, just, we found out we are fine with the k-means clustering. That's it. Other than this, nothing is there. That's how, we think. But to find out the technology of finding out the center point, it takes its own time. If you are dealing with millions and millions of data, then you might know the those kind of effectiveness. Okay, so these are all things. Still out score. Those are very simple to how to apply. That's what we are going to see. Um, Stopping points. These are the implementation in this same. Maybe you can also try this information. Yeah, how the clusters are different. Original points. They are just, each and every step they wanted to visualize. That is why, they are nice higher number of clusters. Uh, this is the k means plus plus. That is an algorithm that can be used to choose the initial values or the initial clusters and parts for k means. Okay. Here, I want to show you how the elbow methodology works. These are all very simple items there. Okay. So okay, the maximum possible number of clusters will be equal to the number of observations in the data sets. But then how can we decide the optimal number of clusters? So one thing we can do is plot a graph, also known as an elbow curve, where the x-axis will represent the number of clusters and y-axis will be an evaluation metric. We'll start with a small cluster value, say 2. Here also, you have to go on a trial and error basis to find out how many clusters you should have in a problem statement. Okay. So train the model using 2 clusters, calculate the inertia for that model, and finally plot it in the above graph. Okay. So initially, so now we will increase the number of clusters into, train the model again and plot the inertia, and this plot is like this. Okay, so this is the number 2, cluster, and they are just wanted to increase the clusters. When we change the cluster value from 2 to 4, of this C, this is the value, the inertia value reduced sharply. This decrease in the inertia value reduces and eventually becomes constant as we increase the number of clusters further. And so the cluster value where this decrease in inertia value becomes constant can be chosen as the right cluster value for our data. So this is the technique of choosing the right k value or right number of clusters. Okay, so wherever it just stopped and it is just going like the constant value. It started from this. Okay, it started from 6. It is slowly decreases, and from 10th point onwards, it looks like constant value. It is not changing that much, but it is a drastic change. If you choose 2, right, and also 4, there are so many deviations from this cluster to this cluster. So this could, I mean, wherever you are finding it out, the constant change, same like here, where it is the constant value, it is going from the 5th point. Okay, so this 5th point would be our right K value. Let's see how. Yeah. So after this graph, this elbow method, and they are just trying to choose the right K value, I mean the clusters, number of clusters. And then only they are trying to training this model. Okay. Uh, so this is the key, where it is getting started as a constant value. This doesn't have too much of deviation. It looks like more or less, it looks like it is getting into constant. Where would be the starting point? That is your ideal number of clusters you have to take it. If you take this, maybe 3 or 4. I mean, there is no 4 over here. Maybe this elbow. Elbow is nothing but the point it gets just deviated. Okay. It is just again it is decreasing the value, and then from here it is not we couldn't find out this kind of an elbow technique. It stops over here. Just see the data. Even if you just go with more number of clusters, that would be the case. Okay. So this is how you have to select the number of clusters. Selecting the number of clusters does matter a lot in k-means clustering. That's it. Okay. So for that, we are using elbow method to um, use this elbow method. You can use this, the k-means importing technique, and then for plotting the graph, this is what all the things you have to consider for x and y, and then initialize the k-means. Here itself, you are just taking all the value, because to find out the number of clusters. This is the best tech. I mean, number one technology. Before, I mean, this could be the pre-processing information. See, at the pre-processing data step, here it is the finding out the optimal number of clusters. There is no standardization. There is no standard scalar methodology. This is the methodology to find, because this is the unsupervised learning model. That is why it doesn't follow any kind of a usual structure of supervised learning. So yesterday you are asking, is this the same method we are also following for any other, I mean, any other algorithm? No, it depends on the um, kind of data you are dealing with. Okay, so can you just start? Maybe Sai, since if I just import this, and then we'll just see how it is happening. We'll just see the elbow method, and then train the model, and then again trying to make it the visualization. Maybe you can just go with this link, or you can take it any other thing, because we don't want to go with the same thing. I will share this in chat.
Chat.
Maybe
Okay.
you can take it, or we can try to make it in GitHub. I mean, it's up to you. Maybe we can work on this analytics with the code. That's it. I mean, they are also taking it from GitHub only, so it is.
GitHub
It's,
only.
it's, This is a wholesale customers data. So you
Okay.
can just import this data, and then I will give you
Yeah.
the access.
So, okay. Share in the link, I can use that.
I, I have I've shared. I made a host.
In chat you have shared or WhatsApp? Yeah.
Through chat, I have shared. You found it.
Ah, yeah, yeah, found. Sharing my screen.
Okay.